as we look into section 8.2, the law of cosines. Here, the law of cosines. So just like we had the law of sines, just based on the triangles that were given, we're trying to solve a triangle for the 6 different parts. So here's how you solve for, or use law of sines to find one of them. So if I'm looking for a side, and all of these are solved for a side. So a squared, so that means it's squared, right? So you're going to have to square root your answer here. I take the other 2 sides and square them, okay, add them together, and then subtract 2 times those 2 sides, cosine of the opposite, the angle opposite the side you're trying to solve for, okay? So whatever side you're trying to solve for, you're always going to be, everything's squared in here with the sides. It's kind of your Pythagorean theorem, basically. Let's see. And so you will square your sides that you do have, and you'll add them together. And then you'll subtract, taking those 2 sides, multiply them together times 2, and then timesing them by cosine of the angle that you're given. And that angle is always going to be opposite from the side that you want to solve for, okay? So this would be then a plus b squared plus b squared minus 2ab cosine. Here's my side that I'm looking for, so I'm going to have to use that angle. So that is the law of cosines. So let's go ahead and do some problems here of solving this. So just like on law of sines, you're solving a triangle. So we want to look at what type of triangle this might be, you know, side, angle, side. So here I'm given an angle. So go ahead and pick whatever that angle is. So here's C, here's A, here's B. So I'm given C. I have A, so I have that. And I have B, so I'm given that. I'm given this angle C. So that means, even though there we go, 5.71. Okay, so that means I have side, angle, side. So I have SAS. Okay, and there's some different cases of dealing with side, angle, side, and how we want to do it. So we want to find the third side. So we want to find this third side using law of cosines, because normally I can use a squared plus b squared equals c squared, but here I don't have a right triangle. Okay, so I'm going to use law of cosines to find third side. Okay, so that's my step 1 that I'm going to do. Step 2 is going to find the smaller of the 2 remaining angles using the law of sines. So then I use law of sines. Okay, so that's how I do this. And once I have law of sines, once I use that to find smaller angle. So how do I know which one's the smallest? Well, that's going to be whatever opposite side is the smallest side. So A is going to be the smallest angle. Okay, so I'll be finding A. So I'm going to use law of sines for that. And then I can use my rule of a triangle, right? Triangle always adds up to 180. So then I can add these 2 up, subtract them from 180 to find B. So when we do these problems, when we're given 2 sides and an angle in between, we can use law of cosines to find that third side, and then use law of sines to find my other angles. Okay, so that's what we'll do on this problem. Okay, so we are given A and B. So that means we're trying to find C, so we're going to use this one. C squared equals A squared plus B squared minus 2AB cosine of C. Right, and we're given all those pieces as well, right? So we can just plug them in. So, and we're going to have to root this, right? So you can type all this in first, or you can probably put it all into the calculator all at once and get the correct answer. So that's what I'm going to do. I'm going to put a square root and then put in parentheses here my A parentheses, square it, plus, put in parentheses my b, and square it, and then I'm going to subtract 2. I'll probably put in parentheses my a, put in parentheses my b, just like this, and then do cosine of, make sure my calculator is in degrees, because this is in degrees, and then I'm going to hit enter, right? So I want to make sure that's all underneath my radical. So I might have to add an extra parenthesis here at the beginning and at the end. I'm going to have a probably parenthesis right here as well. And then if I want to be extra careful, I could probably put another parentheses in this part and then another parentheses in that part. So I might have 3 parentheses at the end, depending on how your kind of calculator puts it in. Okay, so what I would recommend is doing this problem, looking at the answer, making sure you check it, so then you know what to do on your other problems. Okay, so I'll enter in just like this and see what it comes out to be. Okay, and so when I did it, when I hit this square root button, it looked like this. So I was able to enter it just like this, where I just had 1 parenthesis here around that, 1 parenthesis here, which you might be okay with not even doing that. And then I didn't put in that parenthesis. I didn't put any extra parentheses there. I didn't put that parenthesis there. And I just closed it off right here. I just closed 28 off, 28.3 off. So that's how it looked on my calculator, because it did this look like that in there. And so when I started typing these numbers, this line just continued over top, right? If it doesn't continue over top, then that means you're going to have to add the parentheses, all those extra parentheses probably. So test it out and see if you get this answer. So my C is 2.83. So this is 2.83, this side. So now I have all 3 sides, right? So now that I have all 3 sides, I can go ahead and use law of sines to find out my angle. And so we can find out A, the smaller one, right? So that's smaller from the smallest side. So I want to find out angle A. So sine A would go on top. On bottom would be the side A, equals, and I'm going to use the angle that I'm given, right? That's why I have to find this side C first, because I'm given this is the only angle I'm given. Okay. So that's what I say, 28.3, and then I can use that 2.83, and then I just solve this law of sines. All right, so I'm going to type that in, multiply both sides by 4.21. Okay, so typing that in, I got 0.075. That is not my answer, right? Because I want an angle. So that actually equals sine of A equals that. So I need to do the inverse, sine inverse of this answer. And I just kept that in my calculator, whatever this decimal is, right? And then I got 44.85. And then that's when I rounded it, 45.85. So I waited very end to round it. Okay, so now I have that angle. And now I need to find that third, right? So I have the 28.3. So I want to add up 28.3 plus this 45.85, and then subtract it from 180. And that's my third angle, which is 106.85. 106.85. Okay. And then so that's angle, this was angle A. This would be angle B. This would C was 28.3 degrees, and then we have our 3 sides, right? The side that we found was side C, not side A, and that was the 2.83. Okay, so that's kind of what the process of doing it is, and yeah, so that's how you would do it. Okay, so you use law of cosines to find your side, final side, and then you use law of sines to find one of the angles, and then add up the 2 angles that you get and subtract it from 180. Okay, so that's how it works for those problems. Okay. Okay, so as we look at 24 here, I am given all three sides, A, B, and C. So I want to find these angles, A, B, and C. Okay, so here's where we're going to have to do it a little bit different. We just take that law of cosines and manipulate it a little bit, right? So just pick an angle. I did. That'd be A. So again, you can just pick an angle you want to solve for. So say if you want to solve for angle A, let's just go angle A, okay? So here's law of sines for side A. So that equals B squared plus C squared minus 2BC cosine of B, or cosine of A, sorry. Okay, now what I got to do is just manipulate this formula, right? So here I would go ahead and add this over, and then I would subtract this over, right? So then I have 2BC cosine A, and this would work with all of them as well. So if you want to, you could rewrite these, all of them, like this when we finish here, and just replace the letters, right? So this is B squared plus C squared minus A squared. And then we would divide by 2BC. 2BC. Okay, so this is how it's always going to work. Whatever, and again, this is solving for cosine of A, so then I have to do inverse cosine to actually find the angle. Okay, so you add the two sides. You add the two sides that you have, but you subtract the side opposite of the angle you're trying to find, and then you divide by the two sides that you added times 2. So it looks like that. Okay, and then I'll have to take the cosine inverse of that. Okay, so let's go ahead and type that in. So my B is 47, so I'm going to do 47 squared. And I'm going to start off with a parenthesis. And I can probably just type in 47 squared like that, hit the squared button. Plus C squared, so 58 squared. Then minus 28 squared. So really what I'm doing these parentheses for is for the numerator. And then I'll divide, and I'll put a parenthesis on bottom. I'm always careful, but you might be okay with just doing this. But I would put my B in parentheses down here to let us know it's multiplication, and my C. So this parenthesis might be okay not to do, okay? So I'll go ahead and do that and see what answer I get. And again, this equals cosine of A, all right? All right, so I actually didn't put these parentheses on, so you're good there. But I did have to put these around 47 and 58. Okay, so I got 0.88, and I actually left whatever's in my calculator, and then I hit cosine inverse, so shift cosine answer, and hit enter, and there I get 28.55, which the book actually rounds to 29 degrees. So 29 degrees would work. So now I have this angle, 29 degrees. Now, what I have to do here is I'm just going to have to use, I can use law of sines now, right? Because now I have the two opposite, I have an angle in the opposite of that. So we can just do law of sines, and that's how most of these always are. Use law of cosines first to find one piece, and then you use law of sines. And so this one was 3 sides, and let's see. Yeah, to find 3 sides, we just use law of cosines to find that one angle, and then we use law of sines, yeah. So that's how most of these always are. Okay, so now I can do, what do we want to find? An angle, right? So let's do B, and I know side B, right? 47 equals, now I know angle A, and I know side A, which is 28. So now I can use law of sines. I can multiply both sides by 47, right? So this gets moved in front of this, and it's multiplied. So I can do that. And then I'm going to take the inverse of that answer, right? Sine inverse of that answer. And then so I get for angle B, I get 53 degrees. So now I just need angle C, so I can just add these two up. Here's angle A, here's angle B, and now I can just add those up and subtract from 180, and I get 98. So though I already have my 3 sides, and there's my 3 angles. So that's how you do it when you have 3 sides. And I would manipulate this formula, right? If you plug in a B here, then this would just be A, that would be C, this would be B, and then this would be A and C. And then same thing, put in C, that would be A and B, that would be C, this would be A and B. So you can manipulate that. And again, you're going to have to use inverse to actually find the angle. All right, so let's go ahead and continue some word problems. Really, you're just drawing a triangle, right? So think about this scenario. I have points X and Y on opposite sides of a ravine. So X, Y on the opposite sides of a ravine. And then somewhere I have a third point. From a third point, the angle between the lines of sight. So that means I have a third point somewhere, and my line of sight would be to X, and my line of sight would be to Y. And they say that angle in between that is 37.7 degrees, right? So that angle right there. So this is Z. Do you hear my kids screaming in the background? Because I do. They're going nuts. Okay. And then they say this distance from X to Z is 153. And this distance from Y to Z is 103. And then so I want to find this distance XY, right? So I can go ahead and say, okay, well let's just say that's A, okay? So then I'd use this formula, A squared plus or equals, right? Whatever side I'm trying to find, I add the two other sides that are squared. So 153 squared plus 103 squared minus 2 times those two sides, 153 and 103. And then cosine of the angle opposite the side I'm trying to find, which is 37.7. Now I can actually type this into my calculator. And all I have to do is just square root both sides. And in my calculator, when I square root, it continues this line all the way across. So actually, the only parentheses I put around here are the 153, the 103, and the 37.7. And so I just do it like that. I didn't even put parentheses around the 153 or the 103. That's being squared. I just hit my squared button. Okay, and then I got A is equal to 95.29, so 0.3. So that's how many meters? That's the distance that I'm looking for, right? So that's that distance from here to here. Okay, so there's your answer. So just think about the scenario. You're going to use law of cosines because that's what this section's about, and you're going to have a triangle, right? So draw it out. Think about it a little bit, okay? All right, so let's go ahead and look at this one. Find the angle B. So we want to find angle B in the figure. Oh, I need a draw figure for you. Oops, I guess I never did I? Oh, never mind. We're good because I drew it in this one. So you're good. You use that same one on 50. You're just finding theta and I'm finding beta. Okay. So here it's the same thing. It's just, so I am doing cosine of beta would equal the other two sides squared. So that means A squared plus B squared beta. Well, it's the sides that I have, right? So the opposite side of this angle that I'm trying to find would be 16, right? So 16 would not be here in these squared parts. It would be in the subtraction, okay? So that means 20 squared plus 13 squared, and then you subtract the opposite side of the angle you're trying to find. So 16 squared. And then all over 2 of the two sides that are not opposite of the angle you're trying to find. So that'd be 20 and 13. Okay, and again, I'm going to do inverse of this. Okay, so I'm going to type this in again. I'm just going to put the numerator in parentheses when I type this in. Okay, and then I'm going to go ahead and do the cosine inverse of this. So I want to take cosine inverse of 0.602, and it goes on. So I'm just going to do cosine inverse of answer that I have in my calculator, and I get my 52.99, so 53 degrees. So that's B. You have to find theta, okay? But it's the same thing except for you're just going to switch these places, right? You're not going to have 16 here, and you're not going to have 13 here, right? So those are basically going to switch places, right? Okay, and then these would be different for you. Okay, on this last problem, basically you're finding area, right? Again, you're going to be drawing a triangle, you're going to be labeling your sides, and you're going to find the area. Now I have to do maybe a little bit more than you have to on your problem, but I have to find the area, okay? And once I find the area, I'm going to just keep on subtracting 75 until I get to a negative number, and that's however many 75s I subtract, that's how many cans I'll need, right? So I'm going to use what is called, I'll probably pronounce this wrong, but Heron's formula. Heron. Heron. Heron's formula. And so what this formula does is it allows us to solve for the area. Okay, so this allows us to solve for the area, or he also has a formula for the semi-perimeter. So he does two different things. The semi-perimeter, but it's mostly for the area one. So the semi-perimeter is this, and then so that's how I find this S, which you're going to need. Okay, so you're going to need how to find the semi-perimeter, and then that semi-perimeter is used to find the area if I'm given 3 sides of a triangle that's not a right triangle. Okay, and so you take that S and you times it by S minus A, S minus B, and S minus C. So you're going to take that S minus every single one of your sides. You're going to multiply it together, and then you're going to times by S, and then you're going to take the square root. Okay, so that's what it's going to look like. Okay, so let's go ahead and find S first. So we're given S first, and that's 1/2 adding A, B, and C, right? So that's going to be adding 75 plus 68 plus 85. Okay, and then taking half of that. Okay, so I'm going to add those 3 and take half of that, and we'll get that answer. Okay, so we get S is 114. Okay, now we can apply our area formula. So our area formula is just taking S and subtracting from A, subtracting from B, and subtracting from C, multiplying those 3 together, and then times it by S as well, and then taking the square root, right? So I'm going to take this 114, and I'm going to subtract it from 75. I'm going to take 114, subtract from 68, and you could do it all in one, but I'm probably just going to do it separate, and 85. Okay, so I actually wrote down 144, but it's not 144, it's 114. And I did it, so I subtracted it all. I got 39, I got 46, I got 29. So that was me taking my S and subtracting from each side. And now I'm going to find the area, I take the square root of taking that 114 and multiplying it by all those numbers. So I'm just going to multiply my S times S minus each one, and then take the square root. And so my area this is my area. That doesn't answer my question. And it rounds to that, right? So this would be meters square meters. Okay, so, but that's not my answer. That'd be your answer if it just asked for area. It wants to know how many cans. Well, 75 square meters cover the paint can, right? So I'm basically going to take this and divide that by 75, and that will tell me how many cans, right? So if I divide that by 75, that's going to tell me how many cans. So 32.47. So, and it says to the highest number of cans. So that means it's going to take 33 cans. Okay, so that's how I would do it. Yeah. Okay, so that is the end of the video. We're under 30 minutes, so that is good because there's nothing left, I believe. Nothing left. All right.